critical angle, when rays coming from denser media to a rarer media, refraction will occur and the refracted ray will be away from norm. As the angle of incidence is increased, the angle of refraction will increase till we reach a situation when the angle of refraction is 90 degrees. And the rays at that point will come parallel to the surface. In this situation, the angle of incidence is called the critical angle. If the angle of incidence is greater than the critical angle, total internal reflection will occur and rays will not pass to the rare media. Instead, it will be reflected back. This is known as total internal reflection. Now I will discuss some examples where total internal reflection is applied. First, gonioscopy. Angle of antechamber can only be visualized when a gonioscope is used. Rays coming from the angle on reaching the interface between the cornea with a refractive index 1.36 and air with a refractive index of 1 will undergo total internal reflection, so the examiner cannot see the angle. When a gonio lens is applied, air will be replaced by tear film or mesial cellulose. Both are with high refractive index close to that of the cornea. Thus, rays coming from the angle will pass through and reach the examiner's eye. You may see a mirage while you are on the road on a hot day. You will see as if there is water, and as you get closer, it disappears. As the ground becomes hot after exposure to sun, the air also becomes hot. Layer of air closer to the ground becomes very hot, and gradually higher layers of air become less and less hot. The hotter the layer of air, the more it will expand, and its refractive index will become less. Rays coming from an object like a tree or the sky will pass from a denser to a rarer medium and will be refracted away from the norm. As the angle of incidence becomes greater than the critical angle, total internal reflection will occur. If an eye receives these rays, it will be projected back and an image of the tree or the sky will be there. This is an example of mirage seen in the desert. Third example, reflecting prism. Using this phenomena of total internal reflection, prisms can be used as mirror. When right-angle prism is arranged in such a way that rays falling from a denser to a rarer media, total internal reflection will occur, and this surface of a prism will act like a mirror. This reflecting surface has 100% reflectance since it is enclosed in glass, and thus it cannot be dirty. This phenomena can be seen in some slit lamps and in indirect binocular ophthalmoscope. Here, light from a lamp will be reflected into the patient's eye. Here, Light from patient posterior segment passing through the pupil is allowed to spread apart and reach each eye of the examiner. Thus, the examiner with an IPD of 60 to 70 millimeter can receive rays coming from a small area of the patient. Fiber optics is another example. Fiber optics are used for endoscopic examination of different organs. The endoscope has optical system to form an image which pass through bundle of optical fibers to reach to the eyepiece of the instrument. The fiber optic bundle is formed of a core that is transparent and has a high refractive index, surrounded by a coat of substance with low refractive index. Thus, rays passing from denser media of the core will be reflected at the interface and will remain within the core to reach the eyepiece. Finally, decoration lights and magic fountains are examples where total internal reflection is the main force behind.